In this video, I just wanted to talk to you about shapes of molecules. Okay, now shapes of molecules are deduced, or you can figure out the shape of a molecule using this theory called valence shell electron pair repulsion theory. So they call it VSEPR. Okay, now valence shell means outer shell. So you're only going to be interested in the outer shell electrons, okay? Now, electron pair. Now, what do we know about electron pairs? Well, you have two electrons being shared, okay, to make a covalent bond. And the one pair and the next pair will try to repel each other. Repulsion means to push away. Now you know that like charges will repel, unlike charges attract. So valence shell electron pair repulsion theory. That's the theory we're going to be using. Now, I think probably the easiest way to do these is to go through the examples. So I'm going to start with the examples there on page 55 of your textbook. So the first example that they used was beryllium chloride. They asked you to draw the molecule and to deduce the shape of it, to figure out the shape of it. Now, beryllium is in group 2. So what do you know about elements in group 2, or atoms of elements in group 2? They have 2 electrons in their outer shell. Okay, so if I was to draw 2 electrons there in beryllium's outer shell, I need to bond that beryllium, or stick it, glue it, to 2 chlorines, okay? Now remember that I'm going to dot one set of electrons and cross the other. So chlorine is in group 7. So chlorines have, oh sorry, now I should have X'd that there, shouldn't I? Chlorine has 1, 2, 3, 4, 5, 6, 7. So now look, there's one pair of electrons, there's another pair of electrons. Pair implies 2, remember. So you have 1, 2, that's one pair of electrons, and that's the other pair of electrons. Now what those pairs of electrons will do is they will try to repel each other. They will push away from each other as far as they possibly can. So what you'll have then is you'll have a situation where you have the electrons pairs 180 degree angle away from each other. So that's one pair, that's another pair of electrons. Do you see the pair of electrons there? And they have repelled or pushed each as far away from each other as they possibly can. You need to remember the bond angle as well, and you need to remember the name of the shape. So we call that shape linear, and we call the bond, and you need to remember that the bond angle is 180 degrees. Now, I mentioned octet rule in the last video when we were doing ionic bonding, but I didn't talk about exceptions. There are some exceptions to octet's rule. Now remember, I would have told you that atoms want 8 electrons in their outer shell. Now you can clearly see here beryllium doesn't have 8 electrons in its outer shell. It has 1, 2, 3, 4. So that's an exception to octet's rules. Don't overly worry about it. It's an exception. So linear, 180 degrees. Now the next example then, they ask you to draw boron trichloride. So you're drawing boron in the middle. You normally start off with, people sometimes say to me, how do you know which atom to start off by drawing? You normally start off with where there's just the one, you know, so you see the way you've only got the one boron here. Now boron is in group 3. So I'm just going to draw 3 electrons in the outer shell of boron. And then you have to glue or stick or show the bonding of three of the chlorines. Remember, it's outer shell, valence shell electrons that we're just going to show. And the other thing is that you dot the electrons belonging to one atom and cross the electrons belonging to the other atom. You know at this stage the chlorine's in group 7, so you would draw 7 X's there, or crosses, to represent the electrons belonging to each chlorine atom. Now, how many pairs of electrons do we have around the atom? We have 1 pair here, 1 pair here being shared, and 1 pair there being shared. So there are 3 pairs of electrons being shared there. Okay, so what's the what's the greatest angle of repulsion, I suppose I'm trying to say. So these are going to push away from each other as much as they possibly can. So what will happen is you will get a situation where you have a bond angle of 120 between the bonds. So that's an angle of 120 between the bonds there, or they say that the bond angle is 120. Remember, the bond is the glue. that's sticking the boron to the chlorine atom. So it's the pair of electrons that are being shared in there between the two atoms. That's what sticks the atoms together in the molecule. So the bond angle there is 120, and we call that shape triangular planar because it's like a triangle, or trigonal planar. I normally use the word triangular planar, so maybe we'll stick with that. Now, the next example in your book then is they ask you to draw out methane. Now carbon is in group 4, so 1, 2, 3, 4 electrons in the outer shell of carbon, and we're going to bond that, or stick that to, that's a hydrogen there, to 4 hydrogens. You see the way that you have the 4 here? That tells you how many atoms of hydrogen are used in the molecule. So how many pairs of electrons do I have now? 1, 2, 3, 4. So what will those electron pairs do? They will try to repel, push away from each other as much as they possibly can. Now, do you remember, if you're in school now, we'd be using the molecules like we used to use when we were doing organic chemistry. This is methane. Now, you're very familiar with methane. It's the first member of the alkanes. Do you remember what the molecule of methane looked like? So I would have said to you that it was tetrahedral shaped. Remember that word? Tetrahedral. What does that mean? Well, it means that you have 2 bonds lying flat to the plane of the paper. You have one bond sticking out and the other bond sticking in. So these molecules aren't drawn flat. So the angle here is 109.5 between the bonds, okay? So see, sometimes people think 360 divided by 4, that'll give me 90. But they're not flat to the plane of the paper. So if you try to remember methane, or you might have a photograph of it even from when we were doing isomers or something. So, you know, your angle there, you're just going to have to learn your angle. Your bond angle is 109.5, tetrahedral shape, okay? The next one they do then is ammonia, NH3. Nitrogen is in group 5, so 1, 2, 3, 4, 5. And you're going to bond that then to 3 hydrogens. Remember, I know it's 3 hydrogens because of the number 3 there. Now, this is a different sort of a one now. I have 1, 2, 3 bond pairs of electrons, okay? 3 bond pairs of electrons. Bond pairs are electrons that are involved in bonding, in sticking the one atom to the other. But look, lads, I have what's called a lone pair of electrons there as well. Lone pairs of electrons are not involved in bonding, whereas where you have a pair of electrons, 2 pair of electrons around that atom there, around the central atom, but it's not involved in bonding. Now, what you need to remember here is that the lone pairs that are not involved in bonding have greater repulsion. So they're going to push the bond pairs closer together. Now, earlier on, we met an example with boron trichloride where you had 3 bond pairs around the central atom and it was triangular planar, okay, because the 3 pairs were able to split equally. Here now, the lone pair of electrons will push the bond pairs closer together, closing in that angle from 120 to 107. So the angle between the bonds is 107, and we call this shape pyramidal. So pyramidal shape, 107 degrees is the bond angle. Finally then, something like water, okay, H2O. Oxygen is on its own, just the one oxygen atom, so I'm going to draw that first. 1, 2, 3, 4, 5, 6, and I'm bonding that to 2 hydrogens. Again, how do I know 2 hydrogen atoms? Because of the number 2 there. Now look what you notice here. 2 bond pairs. What are bond pairs again? Bond pairs are electron pairs that are directly involved in sticking atoms together, directly involved in bonding. But look, I have 2 lone pairs. What are lone pairs again? They're pairs of electrons not involved in bonding. So they are not sticking hydrogen to oxygen. Now, these lone pairs will push. They have greater repulsion, remember, than the bond pairs of electrons. So the lone pairs of electrons will push the bonds closer together. So you're closing in that angle to 104.5. And we call this V-shaped. Remember, again, I'm not sure if we would have drawn molecules of water with the molecular models, and you will see a very clear V shape, like when you use the models to do so. Okay. Now, one last thing there that I want to do. Sometimes in the exam questions, they might say to you, predict the type of shapes or suggest possible shapes maybe for a molecule with this sort of a formula. Now, they're obviously using general letters there to represent atoms. So that's where you'd have one atom A, doesn't matter what it is, and you have two X's. Now, you know that you have two X's because of the 2 there next to the X, okay? Now, possible shapes. Well, I could have a situation where I have AX like that, okay? And you have 2 bond pairs. That would be linear. But what about where I have 2 bond pairs and 2 lone pairs? That would be V-shaped. So if they ask you, give possible shapes for a molecule with formula like that, watch for the bond pairs. 2 bond pairs. So it could be either linear or V-shaped, okay? What if they said AX3? How many bond pairs have you got? 3. So it would be something like triangular, planar would be the only possible shape there. But what about if they had something like, oh, sorry, I forgot that. So yeah, AX3, that's triangular, planar, if it's like that. But what about if you had this situation? That would be pyramidal, where you had 1 lone pair pushing the 3 bond pairs closer together. So possible shapes there then would have been pyramidal or triangular planar. Okay, thank you. Oh, sorry. One thing I meant to do there before I went from you. Your revision book has a very good diagram or table, look, where it goes through the shapes and the bond angles, because you need to try to remember those now, okay? So do you see here at the back here you have 2 bond pairs. If it's just 2 bond pairs, it's linear. But look, if it's 2 bond pairs and 2 lone pairs, it's V-shaped, because what will the lone pairs do? They'll push the bond pairs, closing in that angle from 180 to 104.5. If you have just 3 bond pairs, it's triangular planar. But if you have 3 bond pairs and a lone pair, what's the lone pair of electrons able to do? Remember, lone pairs of electrons are not involved in bonding, and they will push the bond pairs of electrons closer together, closing in the angle from 120 to 107. 4 bond pairs tetrahedral, you're familiar with that from our organic chemistry. Okay.